Good afternoon, everyone. It's a pleasure to welcome you all to the exciting webinar on automated machine learning. I am Dhanashree Meshram. I will be your host for today's session. In today's fast-paced world of AI and data science, businesses and researchers are constantly looking for ways to speed up the model development process while ensuring accuracy as well as efficiency at the same time. So that's where AutoML comes in. Okay, so it offers automations in feature selections, hyperparameter tunings, model selections, and deployment, making machine learning more accessible and scalable. Okay, so let's dive it. Let's dive into this is our this will be our agenda for today. So firstly, we'll understand what is AutoML. So AutoML is the automated machine learning, which involves automating the process of applying machine learning to the real life or a real world problems. Now, what is the purpose of doing this? So it simplifies the model building process. Okay. So it reduces the manual interventions and accelerates the model development as well as deployment. Okay. So how it works, how it how we will use this and how it matters. Okay. So eventually when we will use this AutoML model, so as we have already, I have already told you, it reduces the need of manual interventions. So it saves time and efforts, which lowers the barriers for non-expert persons or non-expert people. Okay. And which optimizes the model selections as well as hyperparameter tunings. Okay. So these are some of the AutoML libraries which we are going to understand about in the practical orientation part also. Okay, so first is apart from these library, I want to clear that apart from these three libraries, we have multiple open source libraries available. You can explore after the sessions, multiple AutoML libraries. I will give you list of all the AutoML libraries apart from this. Okay, so first is our lazy predict, which is a very fast way to test multiple machine learning models with minimal setups. Okay, then we have H2O, which is a powerful AutoML framework, which is designed for large data set. When it comes to large data set, we can use H2O. Okay, then we'll have AutoGlue, okay, which is an AutoML library, which is optimized for both tabular data as well as deep learning tasks. And this AutoGlue is made from AWS, Amazon Web Services. This is an open source AutoML library. Okay, so we'll understand first about what is lazy predict is. So lazy predict is a lightweight library which is quickly evaluates and wide range of machine learning models. Okay, as its use cases, it is ideal for quickly trying out multiple algorithms on the small to medium data sets. Okay, then we'll have H2O AutoML library. Okay, which is generally used, which is also an open source AutoML library that scales across a data sets of varied size. Okay, it offers advanced functionalities for regression tasks, classification tasks, and time series tasks. What is the use case of this is? It is best for the enterprises with large data sets. Okay, when it comes to large data set, we can use this. Then we'll have AutoGlue. AutoGlue is an open source AutoML library, which is by AWS, which is designed for both ease of use and flexibility. Okay, so it is particularly good at handling tabular, images, and text data as well. So it is perfect for rapid experimentations across a varieties of data sets and tasks. Okay, so let's just explore quickly and then we'll come back again here. Okay, so here we have our lazy predict. Okay, so this is our lazy predict library, which is an open source AutoML library. Okay, so what we are doing here is we are installing our library, which is a lazy predict. We are installing our library, lazy predict library. After that, we are importing our necessary libraries which are importing a lazy predict. We are importing lazy predict, and from there we are importing supervised. Okay, and we are importing a lazy classifier. From sklearn.model selections, we are importing train test split. Okay, and from sklearn.datasets, we are importing load breast cancer dataset. Now, this is an inbuilt dataset which is present within this sklearn.datasets. Okay, as we can see here, this is our sklearn library wherein we'll have this all datasets which is already present within here. Okay, we are taking this breast cancer data set from here. As you can see, these are all the features of this data set. These are the classes, okay, samples per classes, total samples, what are the dimensionalities, what are the features, real, positive. Likewise, we have multiple things here, okay. It is a binary classification data set, basically. Okay, so we are loading that data set directly from our sklearn library. Now, after loading the data set, we are using one variable. Okay, we are using one variable name. We can give any variable name, and we are loading this library here. Okay, load this breast cancer, load underscore breast underscore cancer. Okay, so this is the name of the library which is here within the scikit-learn library. Okay, then we are using the features, all the features, and what is our target variable. Okay, what is the target variable here? Target variable is also called as a dependent variable. Okay, and all the independent variables means all the other features that we are splitting here. Okay, now we are splitting our data set into train and test. Okay, so here we are writing it as test size is 20. Okay, 0.2. That means our train size is as 80%. 80% of data will be going towards the training set and 20% of the data will be towards the testing. Okay. After that, what we are doing is we are initializing our library, AutoML library. Here also we are taking any variable name. You can give whatever the name you want to give. Okay. So we are initializing our library here, lazy classifier. And here we are checking the model prediction here. This variable name wherein we have loaded this library, we are initialized this library, we are fitting this library into our data set, which we have splitted into test and train. Okay. And after that, we are printing the model. Now, it will serve for all the models there, and then we will give us the best model here. As you can see, these are all the models it has served for. Okay. It has tested these many models, and from all these models, we have all the accuracy, balanced accuracy, ROC, and F1 score. Okay, so now what is accuracy? Accuracy works well for balanced data set. When it comes to balanced data set, okay, then it will work. When suppose this accuracy here, if our data set is not balanced or if it is like biased towards certain classes, then this accuracy will not be our sufficient accuracy, will not be a good or what we can say a valid accuracy. So there comes a balanced accuracy. Balanced accuracy means it is the average of recall for each classes. Okay, it is useful for imbalanced data set and it accounts for class distribution. Along to class distribution, we are going to give it. So this is the balanced accuracy. When it comes to ROC or AUC, receiver operating characteristics of area under the curve, which measures the model's availability to distinguish between the class. If suppose this is 0, that means it is not a perfect classifier. If it is 1, if it towards the 1, that means it is a perfect classifier. Likewise, okay. Then we'll have F1 score. F1 score is the harmonic mean of precision as well as recall. Okay. So this is the bifurcation of all this. So from all, like by using this lazy predict, we can see that this model is giving us the better accuracy for all these terms. Okay. And for other models also, it will go through all the models and give you the best model along with the time taken. All these models are there along with the time taken to. Okay. So this is a lazy predict. Then we'll have H2O. H2O is also a AutoML library as we have understood. So here we are installing our H2O library. Okay. For installing our H2O library, what we are doing, we are using this command called as pip install -q H2O. Will install us the library. After that, we are importing our H2O library, and from this H2O.AutoML, AutoML is a automated machine learning. From here, we are importing our H2O AutoML function. Within this, we are calling that. Okay. From scikit-learn or from sklearn.datasets, we are again importing our breast cancer dataset, load breast cancer. Okay, as I have told you earlier only, we have multiple data sets here. Load diabetics, load digits, load files. All these data sets are available within this. Okay, so we are taking this data from here and we are importing our pandas as PD. Okay, so after that, we are initializing our H2O clusters. Okay, so here what we are doing is we are initializing our model. Earlier, what we have done, we have used one variable name and then we have initialized the model for lazy predict. Here we are directly initializing our model. Okay, and here we are using and we are loading our data set. The data set variable name we are giving it as a data, and we are loading this into this variable name called as data. Okay, so here we are using this df, another variable name, and we are making it into the pandas data frame. Okay, we can get into pandas data frame, and this is also one way of doing this. Okay, we can segregate between the target variables. What is the target variable here within our breast cancer data set, and what are the different features here? Okay, so we are converting our pandas data frame to an H2O frame, and we are using this. And since our target variable is a categorical, since like it is in binary class, we are taking the binary classes in zeros and ones. Okay, we are splitting the data into training test. 80% of the data will go to a training set and 20% will go to a test. Okay. After that, we are using our model. We are initializing our model. Here, we are using this maximum models. Maximum models we are using here is 10. Okay. So, maximum model is 10. Seed is equals to 1 means it is a random seed for reproducibility. Okay, it ensures that what when it is running the same, it should give us like AutoML model should run multiple time within the same what we can say reproducibility should occur. Okay, same, since it will go for 10 times. Since we are reaching the 10 models, we are choosing the 10 models, it will again go for one. It will go and it will give you the result for the first model. Then it will again go second model. Second model's result will be displayed. Likewise, it will. So for reproducibility, we are using the seed model. Okay. Then we have the maximum runtime. So here we are taking a maximum runtime of 300. 300 means in seconds, we are taking as a 300 seconds. So it is in minutes. It will be a 5 minutes. Okay. So maximum runtime for each model should be not more than this. Okay. Not more than 5 minutes. Okay. Then displaying the model performance. As we can see here, we are calling our model here. Here we have initialized our model and we are using this leaderboard. Okay. AML.leaderboard. Now what is this? So it will display the rank model. Okay, leaderboard. Leaderboard means wherein we will have the first feature. Within the first feature, we will have the toppers. Okay, which is having the best performance, which are having the best performance will be listed likewise. Okay, so topper will be at the first, then second, then third, then fourth. It will be in sequential manner. Okay, so best model here we are calling that as AML leader. Okay, so leaders will be in the first, second, third, likewise it will test. And as well as whatever the best performances, we are evaluating that with the test data as well. It will go through the training data as well as with the test data. What is the performance with respect to testing? Okay, so let's check this. So after running this, as we can see that after running all these 10 models, we can see these are the AOC, these are the RMSC, these are the MSC, okay, root mean square error. Likewise, we have all these features and we can see here which model is giving us the best accuracy. Okay, the first model here will give us the best accuracy. Okay, this is a precision. Likewise, the second model, third model, fourth model, every model will be after this. Okay. So this is our what? This is our H2O model, which can be useful for large amount of data set. When it comes to bigger data set, we can use this H2O models. Then we'll have AutoGlones. So AutoGlones is a open source AutoML library which allows you to quickly build a high performance machine learning models with minimal efforts. And these models can also be useful for deep learnings. Okay. Like if you want to use it for like tables, if you want to use it for some other unstructured data set, we can use these models. Okay. So here also what we are doing is we are calling the library. For that we are first installing the library. Okay, for installing the library we have this command pip install autoglue. Then we are importing the necessary libraries. From here we are importing from autoglones.tabular we are importing a tabular predictor. From sklearn.dataset again we are importing our breast cancer dataset. From sklearn.model underscore selections, we are importing our train test split. Okay, which will segregate our data set within train as well as test. And we are importing pandas. So here we are again loading our data set. We are loading our data set. We are checking the X variables as well as Y variables. Okay, independent variables and the dependent variables, or what we can say are target variables as well as whatever the other features present within the data sets. We are converting the pandas data frame. Okay, we are converting them into a pandas data frame, except this Y. Okay, we are only taking this, and after that we are taking the Y component. Okay, individually. After that, we are splitting the data into training and test. Here also we are taking a test size as 80-20. So for the test size, we'll have 20% of the data, and for the training, we'll have 80%. Okay. Now here in the predators, we have tabular predators. Okay. Within that, we have labels as in targets. Okay. And here we are calling and we are fitting a trained here. Okay. So now we can initialize and we can see the performance of this train as well as test model. Okay. Here we have called the tabular predictor and we are fitting that into a training data set. And then we will evaluate that into a predator, will evaluate that into for the test also. Okay, this variable name predator will evaluate into the, like whenever the test data will come, it will evaluate for the test performance as well. Okay, so as we can see here, the performance of autogluons. Okay, so here you can see after running this, we'll have all the total data rows will have a 455 total rows we have, and train data columns we have as in 30 columns we have. Okay, so total classes we are having are two classes, 1 and 0. Okay, so after that we can see these are all the models running here, and we can see here at the end we will have the better accuracy. You can see here the model is having here 97% of the probability of the accuracy here. Okay, balanced accuracy, as I have already told you what is accuracy, what is balanced accuracy. Okay, when it comes to imbalanced data set, or when it comes to if our data set is balanced, is biased towards certain class, this accuracy will not play a very good role. Okay, it will not generate, it will not give you the best accuracy. But at that time, the balanced accuracy will work. Okay. So these are some of the terms. These are F1 scores. These are ROC. These are the predictions for the best model. For the best model, we can see the precision is 97%. For the recall, we can see 98%. Okay, so these are the precision, recalls, accuracy, okay, balanced accuracy. I hope all the terms are clear. Let's just go further with the PPT part then. Okay, so here we have understood that we have like AutoML libraries will do what? It will save our time. Okay, simultaneously, if you are manually running any model, so after that you can check it with the lazy predict or any other, like we have apart from the AutoML libraries, these three AutoML libraries, we have other libraries also, like Teapot we have, okay, sklearn we have. So we have other libraries also. Okay, so you can search for all these libraries and you can predict which library will be best suit for you according to your business problem. Okay, so these are all the three libraries that we have understood. First is our lazy predict, second is our H2O, and third is our AutoGlows. Okay, now as comparison of all the AutoML libraries, we can see that the scalability, as when it comes to scalability, our lazy predict is little low as comparison to that of H2O and AutoGlows. Okay, and since it is working on a smaller data set, okay, H2O and AutoGloons actually works on a bigger data set or a wider versions of the data sets as compared to that of lazy predict. Okay, so as like from these three libraries, you can add more libraries here and you can see what are the different, which library will be working for you, which library is best according to you. Likewise, you can also then supported algorithms. These supports a basic models. When it comes to it will only take a basic models. Okay, here it will take an advanced model, and this will take definitely it will going to take a deep learning models. Okay, definitely, because sometimes it is dealing with the tabular data, and as we have seen already, it is dealing with the tabular data. It is useful for varieties of data sets. Okay, it is doing for the rapid experimentation part, tabular, images, text, data. When it comes to all this, we are using this AutoGlows. So in terms of performance, we can see that a lazy predict is giving us a good accuracy, good performance. Here, H2O and AutoGlows is giving us a better performance, or what we can say an excellent performance as comparison to that of lazy predict. Okay. Then we'll have ease of use. Ease of use is, it is easy to use. Okay. It is also intermediate and easy only. It is not very difficult to this. Okay. It is also easy to use only. Best use case for this is fast prototyping. Okay, it will be eventually very fast. Okay, because it is running, it is taking a basic model. That is the reason it is fast prototyping and giving you a fast result as compared to that of H2 and AutoGlows. Okay, but here it is like it will deal with the large size, large scale data set. And here here in AutoGlow, it will take a varieties of data set. It will not it will not only take a one type of data set, like which is a tabular data set. It will take different type of data set. Okay. So it will work for all these. These are the specialities for lazy predict. These are the speciality for H2O. And this is a speciality for AutoGlows. Okay. So choosing the right model or right AutoML library. Okay. According to you, according to whatever the business problem you are facing, according to that, you have to decide which model, which AutoML model is best suited for us. Okay. So when for lazy predict, best for quick comparison of the models. If you want to, like if we are using a machine learning models and if you want a quick comparison between which model I should use, so in that case, you can use the lazy predict. It will give you a quick comparison. It is ideal for initial explorations and simple tasks. Okay. When it comes to H2O, it is best for large scale data sets or large scale production ready solutions. Okay, it is ideal for what? It is ideal for enterprise level applications. Okay, after that we have autoglones. Autoglones is used for experimentation. Okay, it is best for experimentation purposes across different machine learning tasks like tabular, images, or text related tasks. Also, we can use this autoglone library. It is ideal for users looking for flexibility and as well as performance. Okay, so this is some of the things. Then it comes to key takeaways, what you have understood today. Okay, so we have understood that there are multiple AutoML libraries. Okay, not only these three libraries which I have told you. Okay, you can search for multiple AutoML libraries which are open source. So these are all the open source libraries. Apart from these, we have Teapot, we have multiple scikit-learn, we have multiple other libraries we have. Okay, you can search for these libraries and you can make a quick difference between which library is used for which purposes. Okay, so at least we have understood about, okay, these are some of the libraries which we can use for accessing whether which model we should use. If we have a confusions or if you have a doubt that this model is not a good, this model is which model I should use. Instead of like directly taking a model and running manually, this will save time. Okay, and efficiently accelerates the machine learning model development also. Each library has its strength and is suited for different use cases. So you have to identify that which model, which library is useful for which purposes. Okay, according to that, you can use for whatever the business problem, whenever in the future, whatever the business problem will go through projects and other things also. So at that time, you will be able to understand, okay, now this is a business problem. I should use this AutoML library. This will save me, this will save my time. Likewise. Okay. So AutoML will allows non-experts to build a high performance model quickly. Okay. Like if you are a if you are not from this field, if you are using this model is like for the persons who even don't know anything about this. They can also use this and find out the which model is giving us the high performance or which model is the best model. Like also, okay. So while also helping experts streamline their workflows. Okay. Like if you want to use it for like speedily, if you want to, everyone wants to use this model for saving their time. Everyone is dealing with that time. Okay. So for saving the time, we can use this type of the AutoML library. Okay. So this is our quick recap. You just take one quick recap. What is AutoML? So AutoML is in automating machine learning. Okay, which is an automated machine learning, which involves automating the process of applying machine learnings. Okay, machine learning algorithms. It is automating that and making into a real, like whatever the best model is, we can display that accordingly. Okay, so it will save and time and efforts and lowers down the barriers for the non-experts. Okay, it will eventually do all the hyperparameter model selections, everything inside there. Okay, so this is our overview of this model. So in this today's lecture, we have understood about these three libraries. Okay, apart from these three libraries, we have different open source libraries. Now your duty comes when you have to search for all the different other open source AutoML libraries. Okay, and their functions for which library is useful for which purposes. Okay, so this is it for today, guys. Thank you for joining. We'll meet you with a new topic very soon. Okay, thank you.